Hi there, I'm Ling. I'm a software engineer, hobbyist game developer, and recent graduate from the University of Chicago. In this tutorial, we're going to build a Discord AI chatbot that can speak like your favorite character. Before we start, if you have seen that video by any chance, know that this video is something different and more comprehensive, so keep watching to the end. The original tutorial and my first Discord bot started as a joke between me and my friends when we were playing video games. And it really surprised me how popular it became, and a lot of people wanted to build their own bot based on that tutorial. Therefore, I decided to update that tutorial to include more characters, as well as to show you how to find data for your favorite character. Other topics that we will cover here include, but are not limited to, how to train the model, how to deploy the model, common errors you might see during this model training and deployment pipeline, and how to solve them. Moreover, we will cover how to build the bot in Python and how to build it in JavaScript. Lastly, we will cover how to properly deploy the bot to a Discord server and limit it to certain channels, and how to keep the bot running indefinitely. I hope you're excited, and let's jump into the tutorial. First, we are going to find data for our character. My favorite sources are Kaggle, Transcript Wiki, and just random fandom websites that came out from a Google search. And my research process goes like this. I first search on Kaggle to see if there are pre-made dialog dataset. For example, if we search for Rick and Morty, we get this nicely formatted dataset that includes the name of the character and the line they're speaking. If we search for Harry Potter, here is another dataset that includes the character and the sentence they're speaking. Since we're building a chatbot, we need only these two columns in our dataset, the character name and the line they're speaking. So these dialog datasets on Kaggle are perfect for our requirement. Alright, if we succeeded in finding out data on Kaggle, we can move on to the model training step. But what if we cannot find a dataset for our character on Kaggle? For example, if I want to find a dataset for Peppa Pig, it looks like there is no dataset for the character. In this case, we may need to find the raw transcript of the media, be it a video game, a cartoon, or a show. And I've found that Transcript Wiki has some great resources. So here we have a list of movies, shows, video games, musicals, commercials. For example, I was able to find the transcript for Peppa Pig and also movies like Batman on Transcript Wiki. The transcript looks like this. So we have the character name and their actions or the lines they're speaking. We will see shortly how to turn a raw transcript like this into a dataset like those we saw on Kaggle. Besides Transcript Wiki, you may also just Google the name of your media with the keyword transcript. For example, my first bot was based on the game The Word Ends With You, and it has no results either on Kaggle or Transcript Wiki. So what I did was to just Google the name of the game and game transcript. And it just happened that this fandom website has the full game transcript. So be sure to utilize your Google search skills to find data for your character. If, rather than fictional character, you are more interested in real-life character, you may search for interview scripts as your data source. If you want to create a chatbot that speaks like yourself or your friends, you can treat text messages between you and your friends as dialogues and handcraft your dataset. There are tons of ways to get data for your character, so be creative. And now we will look at how to turn raw transcript into a dataset. Now, suppose we have found our raw transcript. Let's see how we can turn it into a 2-column character line dataset. Suppose we take these Peppa Pig transcripts and copy them into a text file. Now we go to Google Colab and upload our data file. Then we create a Google Colab notebook and use this to parse our script. So I'm going to name this parse script.ipynb. And we're going to, from Google Colab, import drive, and then call drive.mount content drive. This will allow us to read the data from our Google Drive. Alright, now that our drive has been mounted, let's import OS and then OS change directory into content drive my drive, and then we see if there is anything in it. Yeah, we have our peppapig.txt. So here we are going to import regular expression to parse our transcript, put the parsed result into a pandas data frame, and export it as a CSV file, just like those we saw on Kaggle. This is going to be our regular expression pattern. You don't have to be a pro in regular expression to understand this part. If we take the pattern to this site, and our test string is Peppa Pig, you will see that we have two match capture groups, the first being the character's name, the second being the line spoken, and also for the second line, Mama Pig, we have the character name and the line being spoken. Great, so that's our regular expression. Now, let's define a dictionary that will store our data. So we know that we need the column name and the column line in our result data frame. And then we open and read the file. For each line, we match it with our regular expression pattern. If there is a match, we extract name and line from this regular expression match, and then append it to our dictionary here. And then we convert this dictionary into a data frame. Now we can inspect the data frame. Cool, so we have the name is Peppa Pig, saying that I'm Peppa Pig, and then George makes a sound, and Mama Pig makes a sound. Great. We can also count the number of lines that belong to our character. So we do sum df name is equal to Peppa Pig. And we saw that Peppa Pig has 38 lines in our entire data frame. So the length of our data frame is over 100, and Peppa Pig has 1/3 of the lines. Great, the last step will be to export the data frame. So df.tocsv, the name will be Peppa Pig, CSV, and we will drop the index. Cool. Now we should have a peppapig.csv in our drive. And here it is, name and line. This is how we parse those raw transcripts into a file that could be used in our model training. So next, let's proceed on to the exciting step, model training. Now we're going to train the model. Go to my GitHub repository linked in the description below and download the content. We're going to use this model train upload workflow.ipynb, which looks like this. Alright, now our file has been downloaded. We unzip the content. And in here we have a model train upload workflow.ipynb. We upload this notebook file to Google Drive and open it in Google Colab. We are going to train a GPT model, which is short for Generative Pre-trained Transformer. In the runtime, change runtime type. Make sure to select GPU because this will accelerate our model training. So now here we mount the drive. We install the Transformers module that we'll be using. And we change directory into my drive. Here are all the modules that we are importing. If we're using the dataset from Kaggle, we need to obtain our API key from Kaggle. So go to our Kaggle profile, go to Account, scroll down to the API key section, create a new API token, and download this file as kaggle.json. We will go back to Google Drive and upload kaggle.json. Now we can download our dataset from Kaggle. We're going to use the Harry Potter dataset as an example. So grab this username and the dataset name, and our file is harrypotter1.csv. Note that because there are white spaces in our file name, we got special characters in the file name. So let's inspect the content of our data file. Well, CSV files are usually separated by commas, hence the name CSV. However, this one looks like it's separated by semicolons. So we need to take care of the semicolons when we're reading the data into a pandas data frame. So separation is semicolon instead of a comma. Cool. So let's sample our data to see what's inside. Alright, so we have character and sentence. Notice that these two column names aren't exactly what we need. We want the two columns of our data frame to be named as name and line, as used down here in this cell. So we need to change the name of our columns. Alright, let's resample our data. Looks like we have successfully changed the name of our columns. Now let's see how big our data is. So it only has 1,000 or so lines, and let's see how many lines our character has. Our character has 155 lines. So here we change our character name to Harry. And we now run this cell to create a context data frame that includes the current line our character is speaking and several lines directly preceding the line. A context data frame is useful here because we are creating a conversational chatbot and we want to generate a response based on the conversation context. So let's sample our context data frame. So in the context of clearly something something, our character responds with seems a pity not to ask her. Great, now we have our dataset. We split the dataset into a training set and a test set. This is because we don't want to overfit the model. In the case of overfitting, the model will just memorize lines from the dataset and talk back to us using the exact lines. We don't want that. We want the conversation to be more organic. So we're only training the model on the training set and evaluating the model on the test set. So we continue running these cells to build datasets, caching checkpoints, and down here we build the model. We will build our model by fine-tuning Microsoft's pre-trained GPT-Small. Small here refers to the number of parameters in the model. There are also a medium and a large model. Generally, the larger the model, the longer it takes to train, but the smarter the model can get. I would recommend training a medium model as it's pretty smart and not too hard to train. My production chatbot that is currently running on a server with 1,000 plus users is also a medium model. For this tutorial, for the sake of time, I'm training just a small model. You can see here it's downloading the model, and this may take some time because it's essentially 300 megabytes. Here are some hyperparameters that you may find useful. For example, train epochs is the number of training epochs. This is defined to be 4 here, and this is the number of times that the model will cycle through the training set. As long as the model is not overfitting, increasing the number of training epochs usually results in smarter models because the model has more time to cycle through the dataset and pick up the nitty-gritty details. There's another hyperparameter called batch size. This is the number of training examples that the model will see in the batch before it updates its gradient. I wouldn't recommend changing this unless you know what you're doing, since other hyperparameters like learning rate and temperature might be sensitive to this change in batch size. However, if you're training a larger model on a larger dataset and are running into memory errors, to make the error go away, it might help to decrease the batch size. The remaining cells have been configured to take in this context data frame we created, train the model, and save it to a folder called output small. Now let's run this main function. Training will take some time. I trained my median model for 12 epochs, and it took around 2 hours, so do sit back and grab a snack while the model is training. You can see the progress in the progress bars above. Alright, here we get back a perplexity tensor. This usually refers to how confused the model is. If a model has a large complexity, it means that the model is pretty confused as to which words to choose to respond to a given situation, and the model might not be very smart. In our case, our dataset is pretty small. It only has 150 plus lines, so it makes sense that the perplexity is high. To decrease the perplexity, we might need to train for more epochs. Cool, but now that the training is complete, we can load and chat with the model here. Alright, let's change the name of the bot. Hello, fellow Red Rider. So let's ask how's Quidditch? There is no such thing as a bad Red Rider. Great, it looks like our chatbot is capable of making and maintaining a conversation. Now we can push the model to Hugging Face and start building our Discord chatbot. Alright, now let's change directory just into the content folder because we'll be doing our push there. And we do pip install Hugging Face command line client. And then we log in using our credentials. Alright, after logging in, we're assigned this token. We need to grab this token for the cell that we need to do afterwards. So we can create a repository to store our model from the command line. Mine is going to be called Dialog GPT Small Harry Potter. And our empty model repository is right here. There is nothing except for the Git attributes file, but we will be adding in the model file soon. Now we install Git LFS, which stands for Git Large File Storage. This will allow us to push and pull all models. And we replace this token with the token we just copied from above. So here's my username and my token. And recall that our training result is stored in this output small directory. And then we change directory into our Dialog GPT small directory because we need to do git add and commit from there. We install the Git LFS and inspect the content of our current directory, which should be Dialog GPT small Harry Potter. And also just print out the working directory we're in to make sure that we are inside content. Cool. Now we check the file status on Git. So these files we need to add to Git. So we do a git add. This will take some time because the PyTorch model.bin is pretty large. And we configure the global username and user email. These are just my Hugging Face credentials. And we commit with message initial commit. And finally, we push the model. It's about 400 megabytes because the PyTorch model is itself about 400 megabytes. Alright, looks like the push is complete. Now we see our PyTorch model here. However, there's one more thing that we need to do before we can converse with the model on Hugging Face. That is, you see here, it's tagged as text generation. However, we know that we are training a chatbot model and we want our model to be conversational. For that purpose, we need to edit the model card. So we create a model card here. And we put in our desired model tags. So our tags is conversational. And we commit our model card. And now our model is correctly tagged as conversational. If we go to the main model page, we can start chatting with the model here. Alright, now that we have pushed our model to Hugging Face, we're ready to use it in our Discord chatbots. Now we have our model, let's build the Discord bot. Here on Discord, I have my server, Links DevLab. I have two channels, one for the Python bot and one for the JavaScript bot. The reason why we have separate channel for the bots is because we don't want the bots to be talking to each other. So after we build the bot, we will learn how to set their permissions correctly so that they don't go outside of their dedicated channel. So we go to Discord's developers page, create an application. We need one application per bot. So our name will be Chatbot, Python. So here we create a bot. And I'm going to name this Harry Potter bot Python and upload an icon. We will be using this API token here when we create our bot in Python. We're going to host our bot on repo.it, so sign up for repo.it and create a new Python repo here. Going to name this Chatbot Python. And in here, we will need to store our API tokens for Hugging Face and Discord as environmental variables. So here is a tab for the secrets for the environment variables. So the first one will be Hugging Face token. And for the value, we will go to our Hugging Face profile, edit profile, API tokens, copy the API token, come back here, and fill in that value. Next, we'll create a Discord token. And for this value, we go to this Discord developers portal and copy the token. We add the token here. And our environment variables are all set. Next, I have the Python file in my GitHub repository called discordbot.py. So we grab the code from here, and I will explain the code line by line. Starting from line 1, we first import the OS module that will help us reading our environment variables. Next, we import modules that are useful for querying the Hugging Face model. Finally, we import the Discord module, and here I have my API URL pointing to my username. And we define the bot as follows. In the init function, it takes in a model name, which for me will be Dialog GPT small Harry Potter. Then we store this API endpoint by concatenating this API URL, which is my profile link, with the model name. Then we retrieve the secret API token from the system environment by looking up os.environment Hugging Face token. Next, we format the header in our request to Hugging Face. For the authorization part, we put in bearer and the Hugging Face token. Next, we define a query method that takes in the payload. We dump the payload as a JSON string and use the request module to make an HTTP post request to the API endpoint using our defined request headers, which contains our Hugging Face API key, and passing in the data. Once the request finishes, it should give us a response object, and we decode it from UTF-8 and load the result as a string and return the string. Next, we define an asynchronous function named onReady. The next two function definitions are based on the Discord API. Both are asynchronous function. The first one is onReady. This function will be called when the bot is logging in. So when the bot is logging in, we will print out logged in as, print out the bot's name and the bot's ID so that we know that the bot is functioning. Next, because our bot is a chatbot, it needs to respond to messages. So onMessage is a method that will be called each time the bot sees a message in the channel. So given the message, if the message is coming from the bot itself, the bot ignores the message and does not reply to it. Otherwise, it will form a query payload with the content of the message. And to make the bot more user-friendly, while the bot is waiting for the HTTP response from the model, we set its status as typing so that the user will know that the bot is generating its response. So this is a synchronous call with message.channel.typing. We call soft.query using the payload and get back the response. If there is a valid generated response, there will be a generated text field in this response, and we'll be able to get that out as the bot's response. Otherwise, there might be an error in the response. We just log out the error message so that we can debug the bot later on. Finally, we use another asynchronous method to send the bot's response to the channel using message.channel.send. And that's it about our bot definition. In the main function, we just create a bot and pass in the model name. So for me, this is DialogGPT small, Harry Potter. And use client.run, looking up the Discord token from the environment variables. Great, now that our bot should be all set up, let's invite the bot to our channel. In the OAuth2 tab, we are going to select the bot. And for the bot permissions, the only thing it needs is to send messages. So we copy this URL, paste it in a new browser window, and invite it to my server. Alright, now that we see that our bot has appeared, however, it shows as offline, so we need to run the repo. So we hit run here. And repo.it is installing all our dependencies and imports. Great! Now that our bot has logged in as Harry Potter bot Python, and this is its unique ID. Let's go to the server, and now that the bot is online, I don't want the bot to appear in the general channel, so we go to the channel setting, permissions, advanced permissions, add the bot, and we remove its permission to send messages and save the changes. Now, let's see what happens if I type something in the general channel. Nothing should happen because the bot shouldn't be able to send a message. Nothing happens although the bot is online. And Now this bot should work in this Python bot channel, so let's do hello. And we briefly saw that there's a typing prompt. Cool. So yeah, this is how we built a bot in Python. One thing to know in our repo.it is that because we took away the bot's permission to send messages in the general channel, it is showing an exception, and this is totally okay. If you don't like seeing this exception, you can use a try except block and log out this exception. Great. So now we're going to repeat the process for the JavaScript bot. So we go back to the Discord developer portal and create new application. This time I'm going to call it Chatbot JavaScript. And we'll create a bot. Back to repo.it, we create a node.js app. Going to call it Chatbot.js. We again create two environmental variables. The first one is Hugging Face token. Copying my API token from my profile, added profile, put it in here, and copy my Discord bot token, call this one Discord token, and adding the value. Great, now we have our environment variable set up. Go to my GitHub repository. There is a discordbot.js file that contains the code that we will use for this JavaScript chatbot. Let's copy paste, and I will go through the code line by line. So first we import the Discord API for the JavaScript module, and we import fetch for making HTTP requests, just like we did in Python. And we initialize a new Discord client and define the model URL just as my username and the model name. So this guy is DialogGPT small, Harry Potter. And this is the same callback that is called when the bot is ready, just like the onReady function we saw in Python. So when the bot is ready and logged in, we print out logged in as client user.tag. And here is another callback, this time on message. We use an asynchronous callback because we are making HTTP requests. Like in the Python script, we ignore the message if the message is from the bot itself, by checking if message.author is the bot. Then we form the payload. So the payload is a dictionary containing inputs with text message.content, which is the message that the bot has received. And we form the request headers by, again, using the Hugging Face API key. So we read the Hugging Face token from the environment, process.env.huggingfacetoken, and form the headers. Right before we start making the HTTP request, we set the bot status to typing. Now we query the server. So the response is the result from this call to fetch using HTTP post, given the payload as the body, and the headers using the Hugging Face token. And we convert the response into JSON format and extract out the generated text field. If there isn't a generated text field in the response, but instead the response contains an error field, this means that the bot has encountered some errors and we may want to print out the error for further debugging. Now that we have the bot's response, we can clear out its typing status and send the message to the channel as a reply. This ends the definition of our client.onMessage call. Down here, we log in using the Discord token. Now let's invite the bot to our server. So we go to OAuth, check the bot. Its only permission is to send messages. We copy this, paste in a new browser window, and invite it to our server. Great, looks like we have another bot. Remember to click on Save Changes, otherwise the bot's icon wouldn't be showing. Now that we have our bot, however, it's not logged in. So we need to go back to the repo to run our script. But before we run our repo, let's make sure that the bot doesn't have access to the general channel, nor does it have access to the Python channel because it's not supposed to go there. So in permissions, we find this Chatbot JavaScript. Remove its permission to send messages, and always remember to sync the changes. We do the same thing for it on the Python channel. And go to the JS channel. This time, the one we need to remove is the Python bot. So this Python bot shouldn't be able to send messages to this JavaScript channel. Now we go back to run our repo.it. If you see this error, this means that the Discord version.npm is trying to install is wrong. You can see that there are those warnings that the newest Discord module is not compatible with repo.its version of Node or npm. So we need to manually change something in package.json. So here, we just use the older version and rerun it. Now that we are logged in as Chatbot JavaScript 1048, let's go back to our Discord channel. Cool, the Chatbot is also online. Let's see if it responds to our messages. Alright, so this is now an error message telling us that the model is still loading. The model will usually take 1 or 2 minutes to load, so let's give it some time. Great, looks like our bot is responding to us. And because we have set the bot's permissions correctly, the Python bot is not responding to any messages here, and the JavaScript bot shouldn't be able to talk here. And in our general channel, no bot is ever allowed to talk here. Cool. So now we have successfully built the bot both in Python and in JavaScript. One thing to note is that if I close the browser tab for the Python bot, the bot is no longer responding, although it still shows that the bot is online. So in the next part, we're going to look at how to keep the bot running indefinitely in the browser, even when we close the browser tab. In order to get our bot to run indefinitely, we need to create a web server in repo.it and set up a service called Uptime Robot to continuously ping the web server. So this is for the Python bot, and we create a new file called keepalive.py. And we add the code for a web server like this. And in our main.py, we import that part. And down here in the main function, right before the bot runs, we ask it to be kept alive. And we run it. When the code runs, we see a URL shown in this tab. And we copy this URL and bring it to our Uptime Robot service. So here is the Uptime Robots website, and I already have an account, so I'll just go to my dashboard and add a new monitor. Monitor type is going to be HTTPS, friendly name, Discord Python bot. The URL is the one we copied from here. And the monitoring level will be a ping every 5 minutes. That should be sufficient. And finally, we create monitor. And close it. Now, let's see if our Python bot is capable of running indefinitely. Alright, I'm going to close this tab containing my Python script. And it looks like our model is still up. It's just that after some time, the model on Hugging Face backend will reload. But because the bot itself is responding, we know that our web server approach has worked. Now, let's repeat this process for the JavaScript bot. We create a new file called server.js and copy-paste this code. Then we import this part from the file that we just created. Finally, right before the bot runs, we are going to call keep alive. Stop the service and run it. Alright, the server is now ready. We copy this URL, go to Uptime Robot, and add a new monitor. It's again an HTTP monitor, Discord JS bot, and the URL is like this. And we create a monitor. Now we can safely close this browser window and go back to our Discord chat. And the bot is still running. Great, now we're all done. We have a cool Python chatbot and a cool JavaScript chatbot that can run indefinitely. I hope you enjoyed this video. Please subscribe for more content like this, and I'll see you in the next one.